Welcome everybody to our first Friday presentation. We call it First Friday because it's usually the first Friday of the month. This is an odd one because today is the first. So thanks everyone for joining in. I'm Joe Yates. I'm the DC Post President. Usually our Vice President, Captain Dave Harvey, does these presentations, but he's out, so I'm happy to fill in. I'm with Stanley Consultants here in DC, retired Navy, and happy to see everyone virtually here. Today we have a really cool presentation from Mr. John Kluber. He's from Huitt-Zollars, and he'll be talking about using digital twin technology to go beyond replacing like for like. So really cool presentation, and I think you're really going to enjoy it. First Friday is a series that we do here with SAME DC Post, and it helps sustain the profession, our AEC profession, with monthly educational focused presentations that deliver topical and relevant content to our industry. So thanks very much for everyone who's able to join today. So if you could go to the next slide, please, Ms. Bree. All right, so I'd like to, before we start the way we usually do it, if you feel free to turn off your video, you can also please mute, and Bree will be monitoring the chat. So if you have any questions, you could put it in the chat. Anyway, this is also lunchtime here in the Eastern time zone, so feel free to eat. We won't laugh. I might even grab a sandwich myself. So we're going to start this session the way we normally do, which is a moment of silence for all our active duty military and first responders. They all need our thoughts and prayers throughout the world right now. Thanks for that. And then also what we do at every SAME meeting is we start the meeting off officially with the Pledge of Allegiance. So if you could, a virtual Pledge of Allegiance at that. So attention to the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thanks. We'd also, next slide. We'd also like to take a moment to thank all of our sponsors for their support. We can't do these presentations without the generous donations of our sponsors. That's AMT, Black & Veatch, Christopher Consultants, Consigli, Spinello, Stantec, WSP, Jacobs, Woods Peacock, AB Facility Service Solutions, and Arche Consulting. We greatly appreciate your support. The sponsors' support helps us basically meet our society goals, which include providing excellent content for our members, industry and government engagement, helping to build resilient communities, connecting with our future leaders through our student and young member groups, enriching the STEM pipeline, and preparing our military and veterans for life after military service. If you're not already a DC Post sponsor, we'd love to have you join. Just visit our website, and you can see who to contact and how to become a DC Post sponsor. Post sponsors, among other things, get their cool logo on each presentation. So thanks very much for that. Okay, and now on to the main program. So next slide. Here we go. So these are the learning objectives. I'm not going to read the learning objectives, but you do get a PDH for attending this session. So thanks very much for that. Right now, what I'm going to do is I'm going to move forward. You can read this at your leisure and introduce our presenter, John Kluber. John's the Vice President of Huitt-Zollars MEP Engineering Practice. He provides leadership for the firm's MEP's disciplines and leads business development initiatives across all market sectors. He brings 30 years of diverse experience as a mechanical engineer in the education, federal, industrial, and healthcare markets. He's a licensed engineer and lead accredited professional. In addition, he's demonstrated technical proficiencies with certifications in healthcare construction management, healthcare facility management and design, high performance building design, energy management systems, and plumbing design. He has his bachelor of mechanical engineering from Georgia Tech, my graduate school alma mater. So happy to see someone from back home, and an MBA from the University of Michigan. He's a recipient of multiple awards and civic honors, including the Georgia Tech College of Engineering Outstanding Young Engineer Alumni Award. He currently serves as advisory board chair for the SMU Mechanical Engineering Design Department at the Bobby B. Lyle School of Engineering. So John, we greatly appreciate you joining us today. I believe you're in Texas. So thanks very much for coming in today. And if you're ready, I'd like to turn the program over to you.
Fantastic. Okay, very good. All right, I'm going to share my screen. And I'm going to share, oops, I'm going to get the other one. I am going to switch. I'm sorry, stop for a second. I'm going to. All right, let's go. Okay, so I want to share my screen. Can you see my screen?
Not yet.
Do it again. Can you see my screen now?
No, we just see you and
how about
Georgia
this?
Tech B back there. Oh, now we got there. There we go. Now we got it.
All right, very good.
Yeah, now we can see.
Okay, so
It's all good.
you. All right, very good. All right. I'm gonna switch these displays here. Very good. Okay, thank you very much, Joe. I really appreciate this. This is I'm really excited about presenting this. It's a field that I hope that you find really interesting in these case studies. As we move forward here, I want to tell you a little bit about Hewitt Zollars. We are a fully integrated design firm. We have architects, interior designers, we have urban planners and landscape architects. And then on the engineering side, we provide civil, mechanical, electrical, plumbing, fire protection, fire alarm systems, information technology, structural engineering, as well as consulting services in energy and sustainability. So we do have a national presence. We have 20 offices throughout the United States, and we are in several markets. We're in the federal, institutional, and that includes higher ed and K through 12, science, technology, and healthcare, industrial, corporate, commercial, public works, and transportation. So we're very diverse in our offerings. I would like to just thank Jim Wink here. Jim is he's also a retired naval officer, and he's managing our Hewitt Zollars. We call it our National Capital Region office. It's Virginia. He's the former CB, and he's managed, like me, projects throughout the United States and overseas. He's a professional engineer, and he's got a bachelor's in chemical engineering as well as a master's in civil engineering. So Jim and I, we actually worked together previously at Jacobs in similar roles. And there's me. And again, I appreciate the introduction, but you can see I'm a lifelong learner. I've got lots of certifications, and I think that a lot of that's transferable in markets and such. So I won't go any further on that. And the learning objectives, it's just, we've covered this a little bit, you can read these, but we're going to look at 3 case studies, and they get more complex and the use of technology and digital twins and BIM. Okay, so this is a quote from a famous person. His name is Jim Wink. I like Jim. He said something that really resonated with me. He said, problems they become opportunities when the right people get together. And I really find that to be true, because as you innovate, you really have to have, number one, you have to be experts in what you do, but you have to have an open mind and accept new ideas and concepts and get into this. What if we do this? And if you surround yourself with the right people, you can do amazing things. And I've seen so many things that we've done as a practice in my career that we were able to just do amazing things. Now, I can say today, I think that we're in the forefront. There's a paradigm shift in how we design. And I can remember we went from the boards uh, to CAD, and now we're going CAD Revit, and now we're actually going from Revit to operational models, building models, which are those are digital twins. So the first one, this case study, I call it this for a hospital, and I call this the lemon to lemonade case. And what you're seeing here is all this piping we installed, we designed is for a PET CT, and it's a very expensive piece of equipment, scan equipment. And this system here that we designed was to cool that equipment. The problem is that it didn't work. And so, came in and they said, look, we're not be able to, cool this equipment down. And so I went through my notes. It was obviously something I've done this hundreds, if not thousands of projects. And this one really it was my own personal project. I did all the field work and met with the facilities people. And we were told specifically to tie off from a chilled water line. And there's two different chilled water lines in the hospital. One's for process, one's for chilled water, and one's at 42 and one's at 52. And I told the engineers that worked for me as well. I said, look, we did exactly what we were supposed to do. So I met with the director of engineering. They were able to hot tap it and find the right pipe. And I met with the director of engineering. I said, nobody should walk into a mechanical room, especially in a hospital, and not know the piping systems. And he agreed with that. And he said, well, we've had a lot of changes in there, and people have retired, and we just lost control of the piping systems. And I said, I came prepared to talk to you about a plan that we can go and document all this for you. And he said, look, we don't need, our guys, we're not CAD techs and things like that. We want something very simple. In fact, he said, I want something easy peasy. And I said, well, can you guys open up Bluebeam or, PDF? And he said, yeah, we're not idiots. We can actually, we can open up a PDF, John. And I said, okay, great. And so I said, what do you have? And he says he's got Bluebeam and Adobe and such. And so I said, great. Here's what we're going to do for you. So what you're looking at right now, this is a digital scan, and you see these orbs. These are scans over here and here, and they can be geospatially linked. That allows us to create a digital record of the space. So here's what we're going to do. We're going to go through, we're going to go out there, we're going to review the existing documents, we're going to scan everything, go to Revit. And this is a one-line diagram. These are what engineers like to do, and you should be able to describe systems and piping and flow rates and connected loads and such. So we'll do that for you. We'll find everything, and then we'll do we'll create a hydronic database that's cloud-based that you'll both share. And last, then you'll have a dynamic 2D and 3D PDFs. So it's really simple, right? It's very, very simple. And this is kind of what it looked like. He liked the idea. And so we went in, we put the metadata in, and this is what the scans look like. And they can come into a room and they can pull up anything. And they can see all the pipes and such and where it's going through the hospital. And they can flip it around and look at it. It's very easy to use, intuitive. And then, we had a cloud-based, this is called Smartsheets, that's what I like. And we could attach, files, operational manual submittals, things like that. And we had some, data that we saw, the horsepower, age of the pump, things like that. They really like this. They could use this and keep everything updated. And then if they go in there and like they, click down a pipe, they can say, okay, what is that thing? It's an inch and a quarter. And so it's really easy for them to use. And they really liked it. In fact, I saw the director of engineering about 6 months ago at a holiday party, and he said, that has helped us quite a bit. We've been in situations before where we're going to install like an MRI machine and things like that. We found that had been a problem and such. So it's been very, very helpful. So it's a great tool. And I'll tell you, this is not a digital twin. And I've been in presentations like this and people show this, and it's just all this is no more than just drafting, and we just annotated with the objects with some data. This is not a digital twin. So there's so much noise out there about what a digital twin is, and a digital twin is truly an operational model. It's a dynamic model, and that's so. This is more of a red herring. And the third case is with the same hospital because we did do we did all that. The second case study. This is actually where we did do everything in BIM, and this is for UNT. It's one of the fastest growing, if not the fastest growing university in the United States. They have 3 campuses. They're building another one. This facility was built in the 80s as a missile factory for TI. It was for the Reagan Star Wars defense program, if you remember all that, and it was canceled. And so UNT was able to procure this whole site on 300 acres. This is about 700,000 square foot building, and it's all lab functions. And they do the College of Engineering there as well, but it's a 24/7 facility. And so the university went out for an RFQ, and they did a study, and they said, okay, it came funding $20 million. It was going to be a 5-year project because they could not have any disruption in research and instruction. And they had some very, idealistic. We're going to replace this, the equipment, and through the walkthroughs and such, I saw it was really, the strategy was placed like for like, and so we got involved with them. I did win the project. I'll show you the presentation, but we came down. We identified 29 goals and objectives, and I'm not going to go through them all, but it was really basically about 3 things. And it was life safety is critical, operation and maintenance, and energy and sustainability. And so what we proposed, when you get involved in these projects, you get these old drawings and such. And this was the original plan and you can see on the perimeter, you have air handling equipment, every floor, lots of air handlers, and basically flooding a space with all these supply ducts. And then down this, the center, there's exhaust systems. And then what the university did, they came in, they put circulation, classrooms, and labs and such. Well, the mechanical systems are very much integrated in the architecture. In this case, they weren't. And you could see when you looked at the walls, they didn't go to deck. And these labs, you have to have pressure maps and such, and you have to protect your processes and people and cascading pressures. You can't do that. They communicate. There's no fire ratings and such. So I just saw, replacing this equipment wasn't going to really solve the problem. The real true problems. And because this whole building is really a return planning now. And we know that fires, don't kill people in buildings. It's the smoke that kills people. So, we went in, and if you look at the roof, they have all these ventilators here, and they're allowing moisture to come in the building. And so there's no temperature and humidity control. And so we're saying, all right, you got to fix the envelope, and to go like for like, it's just not it's not feasible. So we came in, and so this was part of the presentation. I said, do not replace it. This equipment, just remove them, and we're going to reuse as much as the infrastructure, and we're going to backfeed the systems. And by the way, you're going to end up recapturing over 10,000 square feet, which is very valuable because they're running out of space. And so we came in and we proposed to put in large penthouse units and backfeed the systems. And this way they could actually have 0 downtime, and they could literally do this in 1 year and save, $4 or $5 million. So they really liked it. And in fact, when I first got involved, the structural engineer said, this is not feasible. And I said, why? And they said, well, you got to strengthen all the girders and joists and everything. There's no way. I said, well, no, wait a minute. Look at the columns. I mean, this was a missile factory, and they looked at the columns, and I said, let's go off the top and have stub columns. And I said, this is about 100,000 pounds of equipment each. And they said, yeah. And they looked at it, and it was, they could do it. And so that was one of those things where, just don't accept it, say, okay, challenge it. And so they said, yes, no problem putting equipment up there. So after we got the notice proceed, we went out there. We started scanning the building immediately, and actually before programming even started. And we took over 600 scans. If you see all these orbs again, that's what these scans are. And we went drones and everything on the roof, and we were able to tie everything together. And and so what we're doing now is we're not just getting a digital record. What we're doing is we're actually creating our model, our operational model, because now we're going to be using it's not objects, we're embedding the engineering inside of our model. So some of the things that we can see dynamically, we start seeing if we're going to touch these pipes and ducts, we know what the pressure drops are. If we change something, we know instantaneously where the critical path is. We can start dynamically changing things. So we're doing this engineering up front. And some of the things that really came out was like the cost estimating. And I'll go through a little story about the cost because that was our first real conflict with the contractor. The contractor came in late, and in SD we're actually now very far along. So we have so much information. All the unknowns are now becoming known. And so, when we're sitting and look at the air handling equipment, we're saying, okay, the columns are I forget, this is 38 feet or so. And now we're saying these simple air tunnels that we come back and we can feed, the existing infrastructure. So these squares are fans or supply fan motors of redundancy. We went right into COVID, so we were able to beef up the filter ratings. This is really just a step below. It's really healthcare. And then you get the return fans. Now we've put in return systems. Now we can start controlling the air in different areas of the building. And what we've done is, there's dampers here, and we can return the air exhausted out here, and we can bring in air. And these are heat pipes. The technology's been around for 100 years, and we can recapture 60, 70% of energy, and we can come through here. Now the building, these are becoming big fresh air machines, really. So real simple passive technology. And then we did a lot of other things. We had to add a lot of VAV boxes and air valves for labs and such. Now, when we're at this point, we're in beginning about halfway through DD, and the contractor now, the construction manager, a great company, came on board. They came in a little late, and so we had already had a lot of the scope already defined. And because when it started off, they said we have 20 million. Said, no, John, we got 16 million. Oh, and by the way, we want to put a new roof in, and we want $1 million in contingencies and such. And we also had the cup to deal with, and then another firm did that, and that was $5 or $6 million. So the construction manager came on board, and we had we're designing to a budget of $16 million, and I felt very comfortable because I had a lot of information. So the contractors got together, and they said this is a $22 million job, and so the difference, I have a lot of information that they probably don't have. So we got to a point where the design was about to stop, and we said, all right, let's have a meeting of the minds. Let's get together. Let's talk about this, and let's share our numbers. And the contractors are great contractors. They're largest in Texas. They're going nationally. I probably see them someday. The mechanical electrical contractors. So we said, okay, let's look at the numbers. And some of the metrics were sheet metal. They had $3 million. And I said, what was your metric that you used? They said $8 a pound. We went to the model. We said, okay, we have 160,000 pounds. That's 1.2 million. You're at 3 million. There's 2 million right there. We went through all the equipment. We were at 3.5 million, and they're at 5.5 million. It's now 2 million. I said, okay, here's what we're going to do on the equipment. We're going to go ahead, and since we know a lot, our engineering has been done up front. We're going to go out and do a procurement package. Within 4 weeks, we're going to procure it. We're going to assign it to installing contractors, and then we'll know in 4 weeks if 3.5 or 5.5 is the right number. And that's for now. At this point, the cup, the central plant, was designed by another firm, and it was like for like. And we said, hey, we ended up taking, that firm did what they were supposed to do. They did exactly what the client told them to do, go out there, category, get all the pumps and everything. And now that we know the engineering of the building, we have to marry it up to the plant. And it's really, everything was oversized. So we said, okay, right size. So we went out and got all the bids, and sure, it came in 3.5 million. So now we're feeling there's a $4 million, right? That's where, the client is really seeing the power of the information because we did it with piping controls and such. So I'm going to take us to a bit of a fly through, and hopefully should go. All right, so this is part of the model that we generate. Actually, this is for the board and the faculty and such, let them know what's doing. So we have, in front of this is the central utility plant, which I talked about, and this is the new design. And as we fly through around this building, you can see how the new systems are going to tie in to the old systems. And again, we get involved and we don't really know. We have really loose drawings, but these scans are within a millimeter. So as we're going through, you can see all the supply is in red, blue, and green is, the return duct. But you can see we know where all the boxes are, the sensors, transformers, and such. And that was all the dry labs over here, the wet labs. And so when something pops up and you see red, that's existing, it's being removed, like all that system right there. And what's going on now is that as we touch these ducts, we start changing things, we start streamlining it. We're trying to minimize, the resistance. And so remember, there was a photo that we had in there of a service corridor. So when you get in a service corridor, they're just jammed up. And so we want to make sure that we locate all the equipment that's possible in these service corridors. And now you can see the old, you see all the fittings and everything, and now you see the new. And all these are lab hoods. And it took to do it the old way, to put all these fast acting valves that take a second to respond. We had hundreds of these valves and boxes. It would take me personally probably 4 to 6 weeks to size everything. In this model, it took minutes, and it puts it in the model and schedule it automatically. So that's the power. So you see the old, the new, and now we're saying, okay, we're streamlining everything. We're seeing dynamically where is the critical path. We do this, and we add a valve or a control damper. So it's pretty powerful. And also, the owner and the contractors we shared the model, but they can actually go in and have interactive PDF. They go around, see, get oriented before they go in there. Now, I'm going to keep the geek speak to a minimum here, but it's not just right sizing equipment. Mechanical equipment, if it's oversized, it's expensive to install and operate. And so I'm just going to go through. This is a sequence. Now we got the right size chillers, but how you operate is even more important, because if you look at these two lines here, this is on this y-axis. This is the power that consumes from 0 to 100%. Okay, so you can see a 600 ton, 1200 ton, it's about the same. They're really efficient at 0.6 kW. These are really good machines, but they get really good if you're around 35 to 75% down in this area. Okay, and so the original sequence was, okay, you start up one chiller, okay, in this blue line, okay, you need another one, it's not making enough cold water, start up the other one. So the sequence is about 6 sentences, right? What we're saying is we're going to go ahead and we're going to target the sweet spots, okay? And this is just the sequence on the chiller. And so it looks complicated, and it really is complicated unless you have done this so many times. But now you say, okay, you're coming in here, and this is how the energy really is being used in the plant. And this differential is your energy savings. So I hope I didn't bore you with that, but I thought it was pretty clear. So it's called demand flow. And then because we know all the performance of the building, now we're saying the valve schedules, we're showing every valve minimum and maximum flows. And that's what all that's about. Okay. All right, so we're going to walk through the central plant. Now we scanned everything, and on the right side here is all your chiller pumps, and then these are the new chillers in the back of the boilers. But all the piping is very, very accurate. And again, the scans are within a millimeter. And we go up the stairs here, and you can see more pumps, condenser pumps, and such. But all the valves now are identified. And a lot of these valves, we're able to use the valve bodies and replace the actuators. And then we did replace some electrical switchgear and such. And all this color scheme is actually what's out there. So they walk out there, and they can see, it's very obviously accurate model here. So, but it's not just the visuals that's important. It's the fact that it's an operational model. Okay. All right, go through this. Okay, and just a quick comparison from the replace like for like on the on the left side, I'm not going through those, but if you go through it, and you'll have these slides, but you can see how by right sizing the equipment, you can see how much the horsepower changed from like chillers, 600 to 340. I mean, these are big numbers. And the cooling towers, we had 12 fans up there, and now we've got 4. The main thing is just a real high level. We're saving a few $100,000 by right sizing the chillers, and we saved 160,000 just in motors. So that's again, I think sustainability. I define sustainability as if you can get the lowest initial cost and lowest operating costs together. That to me is sustainability. Okay, and then this next fly through is these are the new towers. And these are stainless steel towers, and they have all the cages, OSHA cages and platforms, and can easily, safely operate the equipment and maintain them. Now, what's interesting is the design was to go through and really come in through and just replace that. 12 cells, you can't get underneath there, you can't get to the fans, and these are custom cells, so these are real expensive. And this other design that we have is cheaper than this, believe it or not, which is hard to believe. And you couldn't even get underneath the equipment or anything like that. You had to kind of lay on the ground and get to the valves below. And we have side stream filters and stuff like that. So a good use, good decision making, good use of spending of money. All right, so I'm gonna get out of this thing. All right, see enough of that. All right, now UNT. This is their words. They asked me to help present this case study on a regional level to other universities. They were very, very happy, and it's nice when the client recognizes the effort, but they see a very collaborative approach between us and the contractors. The contractors are saying, we're just not used to seeing this, this level of quality. We're actually giving them all the submittals. We streamlined the process. We gave them, the models so they could fabricate. So this is their words. We did go from 5 years down to basically a year and a half. And we did save them. The bids came in at $15.9 million, and that was with all their, with the roof and everything like that. So we did design to a budget. As far as change orders, I think there's probably about $50,000 in change orders. That was it, because there's some shared neutrals that was allowed 20, 30 years ago, but no more. So they're very happy. We used BIM 360. They could sit there and look at the progress of the set. They could go through, they could navigate, drop on into a building, walk around like a video game and see the design. So that is that one. Here's some photos. You just see the difference. You can get underneath the equipment, and these, it's the old design. In fact, because we knew all the equipment, all these platforms, we were able to do shop drawing quality production for the steel. The steel was actually produced in the parking lot and dropped in. All this was 2 hours of work. They took it out and put it in 2 hours. So that was pretty neat. And then this again, some of the shots of the installation, this overview. And when we gave them the model, we watched the contractor just hits, there's a button, and they got software says fabricate. So they take our model and they fabricate, and they know all the breaks, they know the gauge of metal and such like that. So they can actually go buy the material. And then here's the service vestibules are 8 foot wide. You can get in there, service the equipment now because they don't have any mechanical rooms anymore. It's air conditioned. And then you can see a difference, like, from the new pump to the old pump. It's just pretty amazing. And then the reuse of all the existing mains and such dropping in. All right, now the last one. Remember I told you about that lemonade story? Well, they came back and they had a hospital that was, they had a lot of problems with it. And they said, John, can you come in here and just do a study on this? And we said, sure. Now, I'm going to keep as much as I can. I'm not going to get into technicals, but this is a one-line diagram for the hospital. And so what we're seeing is these squares, these are chillers. And just a quick thing, and these are chiller pumps. These are called primary pumps. And they just pump water through the buildings. And they come back. It's pretty simple concept. And then secondary pumps they deliver it to this building here, to all this air handling equipment, fan coil units. And then this building over here, they do the same thing. These are two 11-story buildings. And then we found that they were actually delivering chilled water and hot water and steam to a building they sold to another hospital. So we just found that. We're like, we're scanning everything. We're like, you know, okay, so they, you know, so that was a big surprise to them. Because again, people lose control of what's going on out there. So we made our operational model, and in the next slides, we went to every mechanical room. Now what's nice is that when we are looking at the piping systems, the energy just to deliver air and water through a building is probably it's much more than it takes to actually produce it through a boiler and chiller. And that's why we're looking at the piping system so much. And from that, we can start looking at the load profiles, and then we can start seeing the performance of the building. And I'll just take you through this is, when we look at loads, we look at what's the chiller doing. And this is the original design. It was 800, it's like 2,600 tons. And now this is what they have today, 3,000 ton chillers. And so we start seeing the flow rates. And then we look at what the primary is doing, the secondary, and then we see if it's matched up to the loads. It's kind of common sense. But, when we start looking at, this is the energy of one of the chillers, the kW per ton, and this is over the points of the capacity over a few thousand hour points. You can see this is not, they're spiking here and there. And the reason being, we showed that they never increased the tower, the condenser, the cooling towers. And that affects the efficiency greatly. So we're like, okay, that's a problem. And we went and we did the forensics of the air handling equipment. And we saw in the 80s, they didn't have good spreadsheets or whatever, but the tonnages were way off. So we saw the original design, and then this is what you really, if you're going to do these conditions, this is really what you need. And some of the air handling units, they bypass coils. And up north, we would put face and bypass dampers so the air could go one path or the other. This was bypassing the cooling coil. So it's really hard to maintain humidity control. And you can see they're trying to maintain 40 relative humidity in the ORs, and they're not. And this is one of the reasons as well. So I think originally just the forensics, it was doomed to start, from the start, and that just got worse. So again, now our hydraulic model, and we're going through, and now that we know all the fittings, and we look at the original design, and we went out and we looked at the field conditions, and we can now start calibrating our model with the friction factors. And now we're saying, now we have a calibrated model. Okay. And now that we have the model, we can go through all the electric and gas bills, and when we normalize this through the actual weather data of that time in 2019. And now we have this, and we can get to the load calc. We can start going to our building load, what we came up with, to the utility bills. They're pretty close. The main thing is we're looking at the performance of the building, and that's this EUI, Energy Utilization Index, and the cost index. 344,000 is a lot. That's 344,000 BTUs per square foot per year. And then you say, okay, what should it be? If it's actually down in Texas, it should be like 140, and the DOE says, okay, if it's over here, we had half inpatient, half outpatient. So I'm thinking, yeah, it should be about 150 or so. So they're much higher than they should be. And so then now we're able to go to the manufacturer. Now this is not in our model. We went to the manufacturer of the chillers, and we got the performance, the load. We were able to generate and see how much kW they're actually using a year. And this is for the cooling plant. And that's at 3.6 million kW. And then the ton hours was from our calcs. And we came up with a performance of 0.813 kW per ton, which is pretty good. Now we presented this whole report and study was done for a bunch of engineers, very thorough engineers, very good engineers. And they invited their control people there. And, they weren't, and they basically said, hey, you guys are theoretical, we're real deal. We got the data, we know exactly what's going on. It's like, great. What'd you guys come up with? He said, 0.82. I said, you got to throw me on the bus for 0.13. I mean, you just validated my process. So, but at the end, we were able to give them a lot of information on the financials, and we said, okay, you have a constant primary, constant secondary. That's where you're at 0.813. And if you want your building to start responding to a variable primary, variable secondary with your, it's going to cost you some money. They have a lot in place already, but you get, these paybacks could cost pretty, it's going to save them $50,000 or so. And they're going to save 165,000. So pretty good. But if they want to just get rid of all the secondary pumps, then it's much more, and it's going to take them 8 years. So that's kind of the recommendations, and I think I'm done. Oh no, I got the big finale, the big finish, like the fireworks you guys are going to see. It's going to be all kinds of stuff going on this weekend. So we are at a paradigm shift of how we design buildings. Here's the CAD workflows to the BIM workflows. And really the overarching theme is it's a very dynamic process. The engineering is done up front, and we can use this data. And the data can be transferable to over the life cycle of the building. It can go into the facility side. So I'll go through all these points. You'll have this. But we're finding it's just saving us a lot of time. And oops. And at the end, when I say about time, we can make very informed decisions up front. The quality goes up, our decision making is better, and we can minimize the risk in construction. And we just panned out that one project where we have virtually no change orders. It was pretty compelling. And I think that's it. So I'm going to end my show, and I can turn it over to questions. Hopefully you'll have a few.
Great. Yeah, we have some time here. So Bree, do you have any questions that came through the chat that we could pop through? We're a little ahead of schedule, which is good.
Yeah, we have a couple people that have put some information in. Matt, if you want to ask your question or your comment, if you're there.
Yeah, I'm here. I'm just intrigued how well the customers have been maintaining your data or maintaining their data once you're done, hand it off to them, and they start changing the product around.
That's a good question. That's a great question. In fact, I'm finding in this case, they asked us, this university, they really need to have a BIM execution plan for the university. We laid it all out. They don't even have Revit or anything like that. They're still on AutoCAD. So to what you're saying, they are not. There is no maintaining of the data. Does that make sense?
Oh, definitely. That's always seems to be the problem.
Yeah, I mean, we laid it out and said, look, why don't we have a pilot project? Let's go through it. And we gave them a whole process map of what to do and such. They told you it would take they would have to staff up. They would have to change their platform. They'd probably have to have a staff of people full time to do things like this.
Okay, thanks.
Sure.
All right, John, we have a question from you. If you're available, do you want to ask your question?
Yeah, good afternoon. I was wondering if in the model, if there's a color code or if you can isolate just the PLCs, sensors and actuators, for the control systems.
Yes, it's just filtering. We can do that.
And then has anyone used that as part of their RMF process or, getting authority to operate during the design or construction phase over?
No, we've shared, they can do it. I mean, we've shared the model with them, but yeah, they did not take those. I guess what you're saying is you look at a plan and they can identify that attribute and say that sensor is this and it's controlling this. I think that's what you're asking, right? Yeah.
Yes.
They no, with the we work closely with both control. We had lab control people, right? And then we had the building automation, we had interfaces and such. But yeah, they did not do that.
Thank you.
I'd love to see it. But hey, this is things outside the box, right? Like that first case study. I wish, now I thought about it, I wish we had UR code. You walk in there and you go up there and say, okay, for this, you just walk up there and it can get you, anything you want. Like this is for piping isometric, this floor plans, I mean, that would have been, the next step, and maybe somebody on the call said, hey, that's a great idea because, especially in the critical facilities, I mean, if you have an issue, you gotta get in there and you gotta respond and maybe shut something down quick. And,
Right.
you know, there might be an
Able to
old
isolate
valve
it.
schedule, like, where's valve B14? You know, what I mean, that would be, I wish I would have thought about that, but now I am thinking about it. And I think that the future, we say the future is here now, but I see the next generation, what's going to happen. I think once the load calcs are done in the model, right now we're just transferring that information in. And once that happens, now we're going to start seeing truly regenerative design. Once we get that point, we can start shifting buildings and stuff like that, and understand automatically. Now we're auto sizing everything right now. Once we put that quickly, it only takes a minute to do all of our load calcs in the model. Now we're like automatically sizing, and we don't care if an architect says, I want 4 diffusers. Okay. I want 10. Okay. I mean, we'll just automatically change and automatically size the ductwork. So we're getting rid of all the monotonous drafting and focusing on engineering, because the engineering is now embedded in the model.
Really cool. Thanks.
Sure.
We have another question from Jake. Jake, do you want to
Yes.
ask your question?
Sure. You actually kind of started to touch on it a little bit as you were talking about putting in the loads. And I was just wondering if, we earlier mentioned some weather data and just how well that interface was working, especially as people are kind of more concerned about, say, not so much the maintenance side, but designing to a certain, climatic events that they may not be predicting, but they may want to know how much is it going to cost to go better. You know what I mean?
So see, yes, there's 2 things right there. So the load, it's just not there yet. I think it's going to be coming. Hopefully I'll see it. I'm getting up there, but I think it's going to come quickly. But there's so many great programs out there for the load. And then you're talking about the next step would be the energy analysis. So but we've got some great workarounds, some scripts. If you're using Dynamo, anybody's using Dynamo, we just immediately put it in, find it, and it's very simple to do. But we have some, the programs out there with all that train trace and all that stuff. But it would be nice to have it all embedded. It's just not there yet.
Okay, thanks.
Sure.
And we have a hand up. Fred, do you have a question?
Hello, John. Thank you for the presentation. I just saw through your presentation the pictures that you took through the models, and you identified an illustration with the size of the pipes there. Now, were those pictures taken were those the selected pictures to identify the key components that you did update, or did you was that through like a drone or something like that? I just want to make sure that that illustration where you had the measurements there, that really stood out.
The table, like the calibrated, or
no, the pictures where you had the pipes there. There was a picture, and then there was a model.
The very first one.
Yeah, I was just wondering, was that like through a drone, or like a drone that's going through the building, or do you took like shots at certain points in the?
Yeah, so right, so those orbs, they geospatially link. They have to be line of sight. So in that one room, there's probably 4 scans. They take a minute. What's nice that you can do above ceilings. It's dark, you don't know what's up there. And I mean, we found in some of these, but we found a lot of stuff that they were like, they shouldn't have done. They're putting explosive stuff in regular exhaust. I mean, they're so lucky they didn't blow anything up. But yeah, so the whole thing is they have to be linked geospatially, So that's the only thing. It has to be line of sight.
I see.
That's
so
why,
that I'm. Go ahead. Finish. Sorry.
That's why you have to really know what you want to look at, because if somebody just has one side, you got to get both sides, and based on that, then we know the geometries and such, and then we can start. What you saw was those thin lines. That's just a different view. We could have had it a different view setting and made it actually what the pipes look like.
Okay. That's awesome. So, and that is just basically just using a basic simple digital camera, or just like you took like a video of that.
No, it's they're pretty expensive. These are these are probably can get anywhere from $40,000 to over $100,000. Our company, we scanned for TxDOT 250 buildings, So we, they put them on trucks and go down the road. They can get all this stuff, terrain and everything, and signage, all stuff. So our company owns at least 3 of them. Or you can, you rent it. It could cost, a couple $1,000s to rent the equipment, but it's expensive equipment. You don't want to drop it and stuff.
I appreciate that. So it's similar to like that Google Street View, I suppose, in that case.
Yeah,
Got it.
yeah,
It's awesome. All right. Appreciate it. Thank you.
sure.
I think that's it for hands and questions in the chat. Is there anybody else has some questions?
All
All
right.
right.
Okay.
Great. Well, thanks so much for that. That was super interesting. Especially the cool fly-throughs. That's always great to see that. Get a really good understanding of what the system really physically looks like, as opposed to just paging through drawing sets, which can make things very difficult. So that was very cool. It's super nice to see. So yeah, back to our sponsors. Appreciate your support of this particular First Friday. I'd like to share as we wrap up. I'd like to thank Mr. Kluber for his fantastic and very interesting presentation, not death by PowerPoint, included lots of videos, which is very much appreciated. And I'd like to just in the last couple of minutes left, go through our upcoming program schedule. So this is, like we said before, this is part of our First Friday lunchtime learning session. We do the first Friday of every month. Our next session, which is coming up August 5th, is presented by Fox Rothschild. And it's going to be how to ensure compliance with the Buy American Act. So Buy American Act, lots of, especially federal and DoD contracts, lots of concern about that. So feel free to dial in on that one, sign up for it. To sign up and see what's going on with anything on our post, is just go to SAME.org/DC Post, or you can even just Google SAME DC Post events, and you'll end up at our events page. We also have future First Friday lunch sessions that you can sign up for. I think September is one that we're looking for. So if you have any topic, it could be anything topical. You can go to our webpage and just fill out a form, and then we could try to fit you into a particular time slot. September is one that we're looking for right now. So feel free to anything interesting. I mean, it's PDHs that support our community. So opportunity, if you have something that is cool and that you would like to talk about, that's what we're all about. And with that, I think we have a next slide. Yes, our July 21st, later on this month, is our SAME Top Golf event. Last year was the first year that we did it, and it was tons of fun. So feel free to register now because it fills up. But we buy out a whole section of Top Golf and have our own little reception room and just all kinds of fun. It's all about networking. It's all about meeting your other engineering community professionals and just having a great time at Top Golf. I had never gone to Top Golf until last year, and it was a lot of fun. So feel free to check it out, sign up before we fill up. We're always looking for any sponsors that if you'd like to help sponsor this program. All the proceeds go toward our scholarship program. Each SAME post fundraises for scholarships for college, STEM, and engineering students to help them, get their engineering degree. So, feel free to come and help build our scholarship fund so we can help folks out. We support high school kids in STEM summer camps and, of course, college students with their STEM pursuits. You don't have to be a golfer. I'm not a good golfer. So it's more, if you haven't been to a Top Golf before, it's like bowling meets golf. So you do not have to be a professional golfer. You do not need to bring your golf clubs. Just bring yourself in some fun and you'll have a great time. Okay, sorry, on to the next thing. So we have a whole bunch of stuff coming up. The DC Post is back after a good 2 years of having to deal with COVID. It's fantastic that we're able to have a full slate of events again. So here's everything coming up. In September, we'll have a STEM Expo in conjunction with the Northern Virginia Post and the Mid-Maryland Post at the Joint Base Andrews Air Show. Lots of fun, great opportunity. Philios Angelides in our post is heading that up. There's opportunity, if it's not filled up, if you would like to have a little exposition, a little booth, a little table where you showcase some type of STEM activity that perhaps your company is good at for the kids as they come through. So it's not it's not an industry day, but it's an opportunity if there's something cool that some sort of a little activity that you could have interactive that you could have kids do at your booth, that would be great. Again, information for that's on our website, and Philios Angelides in our post is heading that up. Then we also have just a regular lunch program in September. Our lunch programs are at the Army and Navy Club on Farragut Square. We'll have a presentation about 5G networks and electric infrastructure. Then we'll have a happy hour later in September at Capo, which is a true speakeasy. It's a lot of fun. Don't be surprised when you get there. It looks like a deli, so you got to ask for, hey, is there an SAME event here? And they will lead you through the walk-in freezer door to where the happy hour will be held. So it's lots of fun, all about networking, meeting your fellow professionals here in the DC area. Then later in October, we'll have our true golf tournament. That one you probably do need to know a little bit about golf. It's going to be at Joint Base Andrews, but still intended to be fun and networking oriented, not necessarily hardcore golf. And then last but not least, on the schedule so far in October, we're going to have a Fairfax Water project tour, which should be just lots of fun to get out and see how that system really works, get out, see some real life mechanical engineering and civil engineering. And then we'll have a happy hour after that. So again, the SAME post is all about industry government engagement. So feel free to come out.
Joe, I just want to comment on your slide. You need to correct that the lunch is a.m. Just want to point that out. 11:30 a.m.
Oh yeah, you're right. 11:30 a.m. to 2 p.m. That'd be a really long lunch if it was a reverse in time luncheon. So yeah, thanks. We'll get that fixed. All right. And from big SAME, don't forget the small business conference this year is going to be in Nashville. Last year was in Atlanta. So feel free to register for that. Huge event if you haven't been to a SAME Small Business Conference. A great event for both large businesses networking, small businesses networking, and networking between small and large businesses. So looking forward to that. Left after that. And I think that's it. So Bree, did I miss anything? Are we all good?
You got it all.
All right. Well, again, thanks so much for ending 2 minutes early. And feel free to come to some of our events. Check us out on SAME DC Post events. And worst case, we'll see you at the next First Friday. All right. Well, thanks, everybody, and have a great rest of your day.